So in this video there is something preview of demonstration around for Dredding Project. Is Dredding Project and charting. We are combining multiple techniques like side scan sonar, multi-beam data and charting. So we are prepared the panel for the Dredding survey project. We have a free panel. This is the area that are interested in the Dredding project. So we can see some of these. So we have the multi-beam data for the pre-dredding is like a point. I add to this. So this is the pre-dredding point extract from multi-beam data. You have the following quote extract from the multi-beam data, and you have the post-dredding. After post-dredding you have the following the castor utilities and other like this. You have this, and you have also mapped this area with seabed geology. From side scan sonar we have in the central part fine sand, sand with silt with sand, and sand with silt. So the principal area that are involved in dredding is that. I show you the raster. So there is a very high value at this part, and so you have also value to this area. We are trying to flatten the area and flattening the area to this quote around between around 13.98 meters. So the flattening area will be this. We are also to plot this in QGIS for trees. We are running the plugin with the QGIS for trees, and we are checking this. For this we have this. So we are plotting the two dam and checking the flat plane and the difference. For example, we have the pre-dredding. This is the pre-dredding. It's clear that is under the surface, and we have the post DTM from after the dredding, after the plane of area import in the materials in the area. And so you have some difference between these two DTM. We are also plotting the geologies on the surface. We can show also the position of some CPT and testing and sampling in this area. And we can check also a flat plane. That is the difference between the flat plane like this. This is also a good way to visualize the 3D data, but what I think is really interesting is to do make an analysis of volume that are we are working with it. And so to do this we can do this operation, the raster operation, is the dredding operation. We can save in online way. So you have the raster difference. That the raster difference that represented the height the raster with the height difference between the two situations, the pre-dreading and the post-dreading. After we can do calculation of volume that are dreading in this area, and you can assume the level basis with this value. We can add volume in this. We can save the results on file, for example, results, and also the table, and we run. So we are checking the results in this case. So we have this grid volume that representing effective the volume that was excavated in this area with materials and count pixel. So it's clear that to do that we have to build the pixel, the raster with the same resolution. In this case we are choosing a grid resolution, 0.5 square meters resolution. And so we are doing this. This is the pix value and this kind of value. Great, so this is a great demonstration for a dreading project, and also we can also add panels and starting, for example, charting, final charting of results. Change the name. Okay, also change this. Okay. And making, for example, final maps. We are creating new layout. In this way. We are inside the position. Insert also the key map. and make the legend. So finally export the results.